The most likely cause of a low hot to neutral voltage reading is an open neutral. When the neutral wire is open, the current cannot complete its circuit, resulting in a reduced voltage at the outlet. Other potential causes include loose connections. Poor connections between the wires and the terminals in the outlet box or panel can also result in voltage drop. Hidden damage to the wires, such as a nick or cut, can disrupt the electrical flow and cause voltage fluctuations. The outlet itself could be faulty, causing an open or high resistance connection. A ground fault can create a parallel path for current, resulting in a voltage drop at the outlet. The ground screw that connects the outlet to the metal box may be loose, preventing proper grounding. The path to ground may have high resistance due to corrosion or other factors, resulting in elevated hot to ground and neutral to ground readings. An inductive tester can help identify the hot wire by detecting the presence of an electromagnetic field. The hot to neutral, hot to ground, and neutral to ground voltage readings should be balanced, for example, around 120 volts each for a properly functioning circuit. It's important to further investigate the circuit to determine the root cause of the issue and repair it accordingly. To further elaborate on the possible causes, let's delve deeper into each scenario. Firstly, the open neutral condition is a common culprit, especially in older homes where wiring connections may have degraded over time. The neutral wire provides the return path for the current to flow back to the source, typically the electrical panel. When this path is interrupted, the voltage at the outlet becomes unpredictable, often resulting in a lower than expected reading between the hot and neutral wires. The voltage will then fluctuate based on the load in the circuit. Secondly, loose connections are another frequent offender. Over time, the screws or terminals that secure the wires to the outlet or within the electrical panel can loosen due to vibration, thermal expansion and contraction, or simply poor initial installation. This creates a high resistance point in the circuit, leading to a voltage drop at the outlet. It is imperative to check all connections in the circuit, including the electrical panel. Thirdly, damaged wiring can also contribute to the problem. Wires can be damaged by physical stress, pests, or even corrosion. A nick or cut in the insulation can expose the conductor, leading to a short circuit or a ground fault. This damage can disrupt the flow of current and cause voltage fluctuations at the outlet. It is imperative to turn off the power before checking any wiring. Fourthly, a faulty outlet can also be the source of the issue. Outlets can wear out over time, especially if they are frequently used or subjected to heavy loads. The internal components of the outlet can become loose or corroded, leading to an open or high resistance connection. If other troubleshooting steps do not reveal the problem, replacing the outlet is a worthwhile step. Fifthly, a ground fault can create a parallel path for current. This occurs when a hot wire comes into contact with a grounded surface, such as a metal box or a grounding wire. The current then flows through this unintended path back to the source, resulting in a voltage drop at the outlet. A ground fault can be dangerous and should be addressed immediately. Sixthly, a loose ground screw can also cause problems. The ground screw connects the outlet to the metal box, providing a path for fault current to flow back to the source. If this screw is loose, it can prevent proper grounding, leading to elevated hot to ground and neutral to ground readings. Lastly, high resistance in the grounding path can also contribute to the problem. The grounding path should have a low resistance to ensure that fault current can quickly flow back to the source, tripping a circuit breaker or fuse. If the grounding path has high resistance due to corrosion or other factors, it can result in elevated hot to ground and neutral to ground readings. To further aid in troubleshooting, consider the following additional points. The inductive tester, also known as a non-contact voltage tester, can be a valuable tool for identifying the hot wire. This tester detects the presence of an electromagnetic field around the wire, indicating that it is carrying current. However, it is important to note that an inductive tester may not always be accurate, especially in situations where there is significant electromagnetic interference. Ideally, the hot to neutral, hot to ground, and neutral to ground voltage readings should be balanced. In a typical 120 volt system, each of these readings should be approximately 120 volts. Significant deviations from this balance can indicate a problem in the circuit. When troubleshooting electrical issues, it is always important to prioritize safety. Turn off the power to the circuit before working on any wiring or components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to consult a qualified electrician. To summarize, when encountering odd voltage readings at a duplex receptacle, a systematic approach to troubleshooting is essential. Begin by checking for an open neutral, loose connections, and damaged wiring. If these potential causes are ruled out, consider the possibility of a faulty outlet, a ground fault, a loose ground screw, or high resistance in the grounding path. Remember to use an inductive tester to verify the hot wire and to compare the hot to neutral, hot to ground, and neutral to ground voltage readings. Always prioritize safety and consult a qualified electrician if needed. In addition to the above, consider the age of the wiring in the house. Mid-1940s wiring may be showing its age and could have insulation breakdown or corrosion, which would increase resistance. Aluminum wiring was used for a time and could have issues with the connections to the copper in the outlets. Make sure that the devices you are using, such as the multimeter, is rated for the correct voltage and category for the work you are doing. Category Roman 3 and Roman 4 multimeters are able to handle the higher transient voltages present in residential and commercial electrical systems. Using a lower category rated meter could be a safety hazard. Check for any signs of water intrusion. Water can cause corrosion and create conductive pus that can affect voltage readings. Look for water stains, rust, or dampness around the outlet box. Also, consider the possibility of shared neutrals. In some older homes, multiple circuits may share a common neutral wire. If one of these circuits is overloaded, it can affect the voltage readings on the other circuits. Shared neutrals are generally not permitted by current electrical codes. Look at the wire gauge. Make sure that the wire gauge used for the circuit is appropriate for the amperage rating of the circuit breaker. Using undersized wire can cause voltage drop and overheating. Check to ensure that the electrical panel is properly grounded. A properly grounded panel is essential for safety and can affect voltage readings. Look for a grounding electrode conductor that connects the panel to a grounding electrode, such as a ground rod or a metal water pipe. Regarding the hot to ground reading of 60 volts and the neutral to ground reading of 33 volts at the affected receptacle, and similar readings at other receptacles not on the same circuit but with normal hot to neutral voltage, this suggests a more systemic grounding issue rather than a localized problem at the single receptacle. The fact that the hot to neutral voltage is correct at other receptacles indicates that the problem is likely not an open neutral at the panel or a general supply issue. The voltage differences between hot to ground and neutral to ground suggest that the ground reference is not at the same potential as the neutral. Here's a breakdown of possible causes and how to investigate them. Firstly, check the main grounding electrode conductor connection. This is the wire that connects the electrical panel to the grounding electrode system, typically a ground rod or the metal water service pipe. Ensure that this connection is tight, free from corrosion, and properly sized. A loose or corroded connection can significantly increase the ground resistance. Secondly, inspect the grounding electrode system. Verify that the grounding electrodes are properly installed and in good condition. If using ground rods, ensure they are driven deep enough into the soil and are free from corrosion. If using the metal water service pipe, ensure it is continuous and makes good contact with the earth. Thirdly, check for any breaks or high resistance points in the grounding conductor. The grounding conductor is the wire that runs from the grounding bus in the electrical panel to the various grounding points throughout the house, such as receptacle boxes and metal appliances. Look for any splices or connections that may be loose or corroded. Fourthly, test the ground resistance. Use a ground resistance tester to measure the resistance of the grounding system. The resistance should be as low as possible, ideally less than 25 ohms as per the National Electrical Code (NEC). A high resistance reading indicates a problem with the grounding system. Fifthly, look for any stray currents. Stray currents can flow through the grounding system due to various factors, such as faulty appliances or wiring errors. Use an ammeter to measure the current flowing through the grounding conductor. If you detect a significant current, investigate the source of the current. Sixthly, check for any metal objects that may be inadvertently connected to ground. Metal objects that are in contact with the earth, such as metal fences or underground pipes, can become part of the grounding system and affect voltage readings. Ensure that these objects are properly bonded to the grounding system to prevent them from becoming a shock hazard. Seventhly, consider the possibility of a neutral to ground fault. A neutral to ground fault can occur when the neutral wire comes into contact with the grounded surface. This can cause current to flow through the grounding system and affect voltage readings. Use a multimeter to check for continuity between the neutral and ground wires. Eighthly, check for proper bonding of metal water pipes. The metal water pipes entering the house must be bonded to the grounding system to ensure that they are at the same potential as the earth. Check the bonding jumper and ensure it is properly connected. Ninthly, inspect for improper wiring in the receptacles. It's possible that the neutral and ground wires are reversed in some of the receptacles. This can cause current to flow through the grounding system and affect voltage readings. Use a receptacle tester to check for proper wiring. Tenthly, review any recent electrical work. If any electrical work has been done recently, such as adding new circuits or replacing outlets, review the work to ensure that it was done correctly and that all connections are tight and properly grounded. The elevated hot to ground and neutral to ground voltage readings in conjunction with the normal hot to neutral voltage reading are indicative of a grounding problem. This issue needs to be addressed to ensure electrical safety and proper equipment operation. The most common cause is a compromised grounding electrode system or a break in the grounding conductor. A systematic inspection of the grounding system along with the tests mentioned above should help identify the source of the problem. Remember to always prioritize safety and consult a qualified electrician if you are not comfortable performing these tests yourself.